So if we only analyze 1% of geospatial data, then by definition, we don't actually know what's buried in the other 99%, but we can make educated guesses about what we're missing. It's likely we're missing crucial early warning signs of maybe ecosystem decline, perhaps some undiscovered biodiversity patterns, maybe even areas where reefs are naturally recovering. So for me, the challenge isn't about collecting more data. I think we already have far more than what we can process. And the real challenge is about developing ways to better extract the insights from what we already have and then being able to make decisions from them. I think probably one of the most important things to realize is that satellites aren't wrong. They're just capturing information at a different scale to drones. For me, one of the most eye-opening differences that I've seen with some of my recent field work is going out to the reef and seeing massive patches of seagrass that in global satellite models have been classified as coral. And so we can't actually tell the difference in the satellite data if it's coral or if it's seagrass. And you go there and go, actually, it's a huge amount of seagrass. And so we have different animals that are likely to live in those different types of habitats as well. And so for me, it's not the satellite data were wrong, but the classification of those satellite images definitely has some improvement to be made. And that's why it's really important to combine both drone and satellite data together. And that's really powerful because satellites can show us the big picture while we can use drones to help us refine the details, which overall leads us to more accurate ecosystem monitoring. And what we hope we're really working towards is better conservation decisions. Sometimes that's aerial drone data, sometimes it's even underwater drone data as well, to look at mapping the density of different features on the reef. And this could also be transported to thinking about how we map the density of features on land as well. So it could be coral cover or it could be tree cover. And so we can do this in high spatial resolution imagery like drones or field survey data, and then use that to train models with satellite data that give us quantitative assessments. So instead of going for the standard categorization of something in a satellite image, we actually start to get density assessments of our different features. So we can get so much more information when we combine those two data types together to give us a lot more information about what's going on in the ecosystem. And then it's also a lot more sensitive to minor environmental changes as well. So where you might get a decline, say 10% in seagrass or tree cover, whatever that variable is that you're looking at, you may not actually be able to tell that categorically there's a difference in it being seagrass or it being a tree, but you can actually get from the satellite data that the density has declined.